In this lecture, we will discuss about negative binomial distribution. So we start with the negative binomial distribution. We start with the example. So a coin is tossed repeatedly until head comes up for sixth time. A coin is tossed repeatedly until heads comes up for sixth time. So what is the probability this happens on the 15th toss? On the 15th toss. So here two things is very important to understand. First is sixth time, second is fifth toss. Okay. Previously, we have studied about the binomial distribution. Binomial distribution says that in a fixed number of trial, we get the success. But here we have success is fixed. यहाँ पर क्या है सक्सेस फिक्स्ड है हमको 6 हेड चाहिए और उसके लिए कितने हमें टॉस करने पड़े दिस इज नॉट फिक्स्ड 6 हेड द 6 हेड हमारे वो चाहे हमारे 6 बार टॉस करने पे आए 7 बार करने पे आए 10 बार करने पे आए 20 बार करने पे आए 25 बार करने पे आए सो ट्रायल्स आर नॉट फिक्स्ड हियर बट सक्सेस इज फिक्स्ड so this is the basic difference between binomial and negative binomial. So we write down this thing as the negative binomial distribution negative binomial distribution is the distribution of the number of trials needed to get rth success rth success. So you remember this thing, number of trials needed to get rh success. So our success is fixed, means rh success is fixed, but the number of trials are not fixed. So we need trials, the number of trials needed to get rh success. So we write down as number of trials in second success. So we can write down as R is equal to 2. Number of trials in 10th success. So number of trials in 10th success. So here we have R is equal to 10. So we our success is fixed. 10th success, second success and 10th success that are fixed. But number of trials are not fixed here. But in binomial, so we write down the definition of binomial also here. So the binomial distribution, so we can compare both the distribution. What is the basic difference between them? The binomial distribution is the distribution of number of successes of number of successes in a fixed number of trials, number of independent trials, fixed number of independent trials. So here we can see this number of successes. So number of successes in fixed number of trials. So fixed number of trials. So here trials are fixed, but number of successes are not fixed. So number of successes in binomial distribution we denoted as x, and fixed number of trials we denoted as n. We denoted as n. So that's why we write down the probability mass function of binomial distribution as, for x successes, ncx p raised to the power x or q raised to the power n minus x. So where x is equal to 0, 1, 2, 3, and so on. So p be the probability of success and q be the probability of failure. So this is the probability mass function of binomial distribution. So here number of success we required. So we calculate the number of successes by putting x equal to 0 success, 1 success, 2 success in a fixed number of trials. So here n is fixed. Okay. Now we move to the further, that means negative binomial distribution. So the negative binomial distribution is the distribution of the number of trials, of the number of trials needed to get a fixed number of successes. Fixed number of successes. So you can compare these two definitions. One is distribution number of trials needed to get a fixed number of success. Here the success is fixed. Here success is fixed. Required number of trials. Required number of trials. But in binomial, trials are fixed. We require the number of successes. So here we can denote it number of successes by R, and the number of trials we can represent it by X. So this is also repeated number of trials. So we get RH success, means R successes. So we write down it. Let us suppose the trials are independent. The trials are independent. So each trial result in one of two possible outcomes. One of two possible outcomes. One of two possible outcomes, either success or failure. Success or failure. So we assume the probability of success. So probability of success we denote it as P. So this depend upon trials, and P be the probability of failure. Here we can write down a probability of failure we denote it as 1 minus P. So for this distribution we use as 1 minus P. So here we represent X. So this X represent the number of trials for RH success. for Rh success. So we write down as the Rh success for Rh success is occur in xth trial. In xth trial. So Rh success is occur in xth trial, which has the probability P. Probability of success we assume as P. So we can say that in a sequence of independent trials, the random variable x denotes the trials at which the Rh success occur. So this R, we can say that R is a fixed integer. So R is fixed integer. So we remember this thing. So R is a fixed integer. So the probability of success, so the probability of success, that means we can say that Rh success, the probability of Rh success, probability of Rh success will occur in xth trial, will occur in xth trial. So it means say that R minus 1th success will occur in x minus 1th trials. So then we can write down as probability of x is equal to x successes. So when xth success, so we consider as the probability p. So p into, so that means x minus 1, r minus 1. So p raised to the power r minus 1 into 1 minus p raised to the power x minus 1 minus r minus 1. So this will happen in r minus 1 success is in x minus 1 trial. So then our xth trial will definitely a success. So the success probability is p. So we multiply by p. So probability of x successes we can write down as, so this can be represented by a combination, that means x minus 1 c r minus 1. Here p can read p raised to the power r and 1 minus p raised to the power x minus r. So this is the probability mass function of negative binomial distribution. So we can write down as, so R successes in X trials. So that means here X we can write down as, so R plus 1, R plus 2. So the value of X will be, so we are talking about the RS success, the X value will be greater than the R. So now the negative binomial distribution has two parameters, has two parameter. One is R and second is P. So R and P are two parameter of negative binomial distribution. So this is the probability mass function. So this is the probability mass function of negative binomial distribution. Note, in short, we can write a PMF of negative binomial distribution, and having two parameters that is denoted as R and P. So when we write down the mean and variance, so here we write down the mean and variance directly. So the mean and variance of negative binomial distribution, negative binomial distribution are, so we can write on mean is equal to mu equal to expectation of x is equal to RQ upon P. RQ upon P, and the variance we denoted as sigma square equal to RQ upon P square. Now we take some questions to understand the distribution. So here we here we understand this, how to apply the negative binomial distribution. So now we take one question related to that. So statement is PAT is required to sell the candy bars to raise money to raise money for the sixth grade field trip. There is a 40% chance of him selling a candy bar, selling a candy bar at each house. He has five candy bars. At all. Let x be the number of houses. So it takes, write the name of distribution. First write the name of distribution with parameters. Second, what is the probability? What is the probability he sell his last candy bar at the 11th house? Last candy bar at the 11th house. Now, first we read the question carefully, that means statement. So Pat is required to sell the candy bars to raise money for the sixth grade field trip. So there is 40% chance of selling him the candy bar at each house. So he has five candy bars. So you can see that he has 5 candy bar. The means our success is fixed. We have 5 candy bar. हमारे पास 5 कैंडी है, तो ये तो हमारी फिक्स हो गई। अब हमारे पास ये फिक्स नहीं है कि उसको हम जब सेल करनी है कैंडीज को, तो हम कितने हाउसेज में जाके, डोर टू डोर हमें जाना है जैसे हाउसेज में, तो कितने हाउसेज में हम सेल कर सकते हैं। ओके, सो दिस विल बी कैलकुलेट। So number of success is fixed, but number of trials are not fixed. So trials are not fixed, so that why we will use the negative binomial distribution. So first we identify which distribution is used to solve such type of problems. So first we read the question carefully, then we see that so 5 candy bars. So that means the success is fixed. हमारे पास 5 कैंडी हैं, अब वो हमें बेचनी है, और 5 कैंडी को बेचने के लिए हम हर हाउस पे जा रहे हैं, तो प्लीज परचेज माई कैंडी। So some are interested to take और some are not interested to take. ओके, तो उसके लिए हमें अब कितने हाउसेस में जाना है 5 कैंडीज को सेल करने के लिए। उसके लिए हो सकता है हमें 10 हाउसेस में जाना पड़े, 12 में जाना पड़े, 15 में जाना पड़े। तो दैट इज नॉट फाइनाइट। ओके, मे बी दैट इज फाइनाइट, बट number of trials are not fixed in how many trials we will sell all the candy bars. So now we do the solution of this. So first we take the probability P. So the probability P for selling the candy bar. So this we can consider as the success. So this we consider as the success. That means he will sell all the candy bar. So there is 40% chance. So probability P is equal to 40%. So this 40% can be written as 40 upon 100. So 40 upon 100 is equal to 4 upon 10 is equal to zero point 0.4. So this is 0.4. Now, so when we calculate the probability P and what is the value of R? So R is equal to 5. So we have 5 candy bar at all. So we have 5 candy bar at all. So now we calculate or we obtain the first part. That means we write the name of distribution. So this it is clear. So when we solve the first part, the name of the distribution is negative binomial distribution. So the name of the distribution is negative binomial distribution. Is negative binomial distribution. So name of the distribution is negative binomial distribution with parameters. So we write down the parameters R and P. So the R is equal to 5 and P be the probability having 0.4. Now we can write down the PMF of this distribution also. The probability of X successes you can write down in this way. So X minus 1 C R minus 1. So R minus 1 means 5 minus 1. P, probability P, zero point 0.4 raised to the power R into 1 minus P. So 0.1 minus 0.4 raised to the power X minus 5, X minus R. So you can write down this probability mass function. So 0.4 raised to the power 5 and 0.6 raised to the power X minus 5. So this is our first part. Now, success is fixed, trials are not fixed. Now we move to the second part. So second part says what is the probability that he shall the last candy bar at the 11th house. So last candy bar at the 11th house. So now here the value of x is equal to 11. So for we solve, that means last candy bar at the 11th house. So that means x is equal to 11. So we calculate the probability for x is equal to 11. So he sell the last candy bar. So that means we write down as x is equal to 11. So this can be written as 11 minus 1 C R minus 1, 5 minus 1 into zero point 0.4 raised to the power 5 into zero point 0.6 raised to the power 11 minus 5. So we can write out 10 C4 and zero point 0.4 raised to the power 5 and 0.6 raised to the power 6. Now we simplify this, so we can get the answer approximately 0.1003. Now we can take a other example also. Next example is an item is produced in large number. An item is produced in large number. The machine is known to produce 5% defectives. Produce 5% defectives. A quality control inspector is examining the items taking at random. What is the probability that the that at least at least 4 items to be examined in order to get two defectives? Two defectives. So here you can see that first probability is given. Probability is 5% for defective items, and success success is given two defectives in at least 4 items to be examined. So कम से कम 4 आइटम हम एग्जामिन करें जिसमें हमें 2 डिफेक्टिव्स मिले. So that means our success is fixed. We require 2 defectives, but trials are not fixed. एटलीस्ट 4 में कम से कम 4, उसके बाद 5 6 जो भी हो सकते हैं. So now we do the solution of this. So let P be the probability of defective items. Probability of defective items. We consider this as a success. Defective items को हम कैसे consider कर रहे हैं? As a success. तो 5% जो items है वो defective produce कर रही है मशीन. तो probability क्या हो जाएगी? P is equal to 5%. So this 5% can be written as 5 by 100. So this can be written as 0.05. So 0.05 is the probability of defective items. Now, we write down as two defectives. Two defectives are to be obtained that can be happens two or more trials. Two or more trials. ओके. सो पहले हमने 2 ही आइटम्स एग्जामिन किए, दोनों में डिफेक्टिव निकला है. तो दिस इज द पॉसिबिलिटी कि जो डिफेक्टिव आइटम्स आ रहे हैं हमारे फर्स्ट सेकंड ट्रायल में ही आ जाए. फर्स्ट ट्रायल में फर्स्ट डिफेक्टिव, सेकंड ट्रायल में सेकंड डिफेक्टिव, और उसके उससे ज्यादा भी हो सकते हैं, दैट मीन्स 3 ट्रायल्स, 4 ट्रायल्स, 5 ट्रायल्स। बट इसने कहा है कि हमें एटलीस्ट 4 आइटम्स टू बी एग्जाम, हमें 4 आइटम एग्जामिन करने हैं और उसमें 2 डिफेक्टिव निकालने हैं। So here we consider defective as a success. So defective item, so we write down the probability. Now we calculate the required probability. So that means here we also use the negative binomial distribution. So here because success is fixed, means 2 defective चाहिए हमें, और कितने number of trials हम, so we use negative binomial distribution, binomial distribution. So the required probability is equal to, अब एटलीस्ट 4 आइटम्स टू बी एग्जामिन, तो वो वी स्टार्ट विद 4, दिस मे बी 5, मे बी 6, और मे बी एंड सो मिनिमम हमें क्या लेने हैं, 4 आइटम्स टू बी एग्जामिन, उसके बाद 5 भी ले सकते हैं, 6 भी ले सकते हैं। अब इट इज नॉट पॉसिबल to solve directly, so we how to solve such type of problems, we can solve such type of problems by using 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 or plus probability of x equal to 3. Total probability is 1, so we do 1 minus this. Now we start with 0, 1, 2 and 3. We can use 0 or 1, so we do not use 0 and 1, because हमें क्या करना है कि 2 डिफेक्टिव आइटम्स हमें चाहिए, और 2 डिफेक्टिव आइटम्स आने के लिए कब कितने ट्रायल करने होंगे, कम से कम 2 ट्रायल करने होंगे, तो 0 ट्रायल से तो बात नहीं बनेगी, तो वी कैन नॉट कंसीडर दिस टर्म ऑल्सो। 1 ट्रायल से भी नहीं बात बनेगी, तो वी कैन नॉट कंसीडर दिस, तो वी कंसीडर ओनली 2। अगर हमने 2 ट्रायल किए, 2 ट्रायल पे दोनों डिफेक्टिव आ गए, और 2 से ज्यादा हम कितना कर सकते हैं, 3 ट्रायल कर सकते हैं। तो वी कैन कैलकुलेट फॉर x इक्वल टू 2 एंड x इक्वल टू 3। सो नाउ दिस वी कैन राइट डाउन एज 1 माइनस probability of x equal to 2. So probability of x equal to 2. So how to write it by using negative binomial distribution? X minus 1. So x is 2. So x minus 1 c r minus 1. r कितना है? r भी 2 है। प्रोबेबिलिटी कितनी है इसकी? प्रोबेबिलिटी है 0.05, रेज टू द पावर r 2 हो गया, इनटू 1 माइनस पी, तो 1 माइनस पी कितना हो गया? 0.95 हो गया, 95 रेज टू द पावर कितना हो गया? x माइनस r हो गया, तो 2 - 2 plus for x equal to 3, so this is 3 minus 1 c, 2 minus 1, and 0.05 raised to the power 2, or 1 minus point, sorry, this you can write down 0.05, this you can write down 0.05, so here we can write 0.05 raised to the power 3 minus 2. So now we simplify this. So when we solve this, so this can be written 1 minus, this is 1c1, 1c1 is 1, so 1c1 is 1, 1 into 0.05 raised to the power 2, or 2 minus 2 means 0, so something raised to the power 0 is 1, so you can write down as 0.95, 0.95 raised to the power 0 means 1, और this is 2c1, 2c1 की वैल्यू क्या होती है? 2 होती है, so this can be written 0.05 raised to the power 2, और ये कितना हो जाएगा? 0.95 raised to the power 1. So when we write down this 1 minus, तो फर्स्ट टर्म हमारा क्या होगा? 0.05 रेज टू द पावर 2, और प्लस 2 इंटू 0.05 रेज टू द पावर 2 into 0.95. So when we simplify this by using calculator or manually, so we get the answer as 0.9927. So 0.9927 is our answer. Okay, so you understand. Now we take one more question related to that. each year Rohan has a 10% chance of winning the trophy their trophy case has a space of 5 trophies. Trophy case has a space of 5 trophies. So let y be the number of years, y be the number of years their case is full, means trophy case is full. So find the mean and standard deviation of y. So here our success is fixed. सक्सेस क्या है हमारी कि हमें हमारे पास 5 ट्रॉफीज का स्पेस है। ये तो हमारी सक्सेस है कि 5 ट्रॉफी का स्पेस है हमारे ट्रॉफी केस में। बट वो 5 ट्रॉफी हम कितने साल में जीत सकते हैं, दिस इज नॉट फिक्स्ड। ओके, सो यू कैन मेक ए ट्रॉफी केस वी हैव 5 ट्रॉफी केस, but number of year are not fixed in how many year we will win all the 5 trophies. Okay, so now this problem also based on negative binomial distribution. This problem also based on negative binomial distribution. So this also based on negative binomial distribution. Now we consider as p be the probability of success, p be the probability of success So here P, what are the chances? Chances are only 10%. So P is equal to 10%. So this can be written as 10 upon 100. So means 1 upon 10 is equal to 0.1. 0.1% chance to winning the trophy. So जब 0.1% chances, जब chances are low, so that means it will take time. So now व्हाट इज अवर आर? सो सक्सेस इज फिक्स्ड, उसके पास जो ट्रॉफी केस है वो कितनी ट्रॉफीज का है? 5 ट्रॉफीज का। तो आर इज फिक्स्ड, so r is 5, but number of years are not fixed. So that means that's why we will use the negative binomial distribution. So we can write down the negative binomial distribution as, so y minus 1 c r minus 1 0.1 raised to the power r into 1 minus zero point 0.1 raised to the power y minus r. So this can be written as y minus 1 c 5 minus 1 into 0.1 raised to the power 5 and 0.9 raised to the power y minus 5. So y be the number of years. So this is our probability mass function of negative binomial distribution. Now here we calculate the mean and standard deviation. So for calculating mean, so mean we denoted as mu or expectation of x, which is rq upon p. So r is 5, q, what is q? So q will be 1 minus p. So 1 minus p means 1 minus 1 upon 10. This gives us 9 upon 10. So in you can write down in fraction or in decimal, no issue for that. So 5 into 9 upon 10 into 1 upon 10. So 10 to 10 cancels. So 9 5 ja 45. So 45 years is average time to win all 5 trophies. Okay, because probability is very low. Now, when we calculate the variance, to calculate the variance, sigma square equal to RQ upon P square. So RQ, so 5 into 9 upon 10 upon 1 upon 100 P square. So this gives us 450. So this gives us 450 years. So here mean is less than the variance. So now when we calculate the standard deviation means square root of variance. So this is equal to square root of 450. So this gives us approximately 21.21 years. 21.21 years. Now we have one more question. You roll a die until you get 4 6s, not consecutive. What is the probability? What is the probability you can write down here is calculate mean and variance. So what is the mean and SD of the number of rolls you will make? So here also सक्सेस इज फिक्स्ड, मतलब 4 6 हमको चाहिए और उसके लिए हमें कितनी बार रोलिंग करना है डाइस को, दिस इज नॉट फिक्स्ड. So when we do the solution of this, so here probability for P be the probability of getting a 6 in rolling of a dice. So this will be 1 by 6 because sample space S having 6 element 1 2 3 4 5 and 6, so each having probability 1 by 6. So P equal to 1 by 6 and R equal to fixed. R is fixed because हमें 4 6 चाहिए. So R is fixed. So when R is fixed, so we can calculate Q. Q is equal to 1 minus P. So this is 1 minus 1 upon 6 is equal to 5 by 6. Now we calculate the value of mean. So mean is equal to mu is equal to RQ upon P. So RQ upon P, so means 4 into 5 by 6 upon 1 by 6, so equal to 20. So we require 20 rolls to get 4 6s. मतलब average of mean time है. Now we calculate the variance. So sigma square is the variance. So RQ upon P square. So RQ upon P square. So 4 into 5 by 6 upon 1 by 36. So this can be 5 4 the 20. So 26 the 120. So this is 120. Now when we calculate the SD, so SD equal to sigma equal to square root of variance. So this gives us 10 point something. So 10.95 approximately. So which is equivalent to 11 rolls. Equivalent to 11 rolls.